but I was like not that. Our options are, like, no, I think it would be better if you were sterile and everything that way as possible. No, but she's like, how come you don't apply?
Oh, okay, that's what. When he wrote that, it was like tablets.
Well, you know,
okay, fine. Mark, what is, I like this topic.
Probably. I may even have a remote thingy. Oh, they have a remote thingy.
Yeah. I'll stand on the desk these days and actually work.
Shocking.
Oh, it's 3 minutes late.
Right.
Okay.
Barbara, you want to said,
Oh, right. Hello? What? Hello, can you hear me? Is this working? Guess not. We have some.
Testing 1, 2, 3.
Hello, AVP? Hello, hello?
Testing. Is this working at all? It's working a little. Can we have it work a little more? Yeah, I think the volume needs to go up a little bit, guys.
Hi, how's the volume on this?
Hello.
Your volume? Hi. Is this actually coming through amplified?
Just, this one's going through a tiny bit.
Okay. Hi, can we have the volume up? Sorry, 1 minute, we're trying to get the volume sorted out at this level. Here we go, that's better. Thank you.
Testing. Oh yeah, this one's working now.
All right, now we have our AV issues sorted out. We'll get underway very shortly.
You started the blue sheet, sorry.
No, I didn't.
I will be happy to.
Okay, Mark's just going to dole out the blue sheets. We already have a note taker, that's Tim Wojcinski, so thank you very much. If we could have a volunteer for Jabber Relay, that would be much appreciated. Anybody? We don't have a reserved chair for the Jabber Relay. Anyone? You got it? Thank you. Thank you, Lee. Okay, I think, if anything, the volume is now a little too high. Does anybody? It's good? Okay. Sounds very loud from up front. Okay, we have the usual, actually, so not so usual note. Well, there's been a slight update. Couldn't tell you where it is, but you're expected to have read this and know how to perform with it. I should just leave that there for a minute. If you are unable to comply with the note well, please depart the room. No? Okay, I'm going to assume that everybody has read that and is able to comply with it. Okay, start a little agenda bash. We'll do a usual quick update on working group document status. Then due to have Julius Krobacek talking about the HomeNet Babel profile and Matthew Boutier about source-specific routing within Babel. We then got Ted talking about the naming architecture and service discovery documents that we have, and sort of the three latter drafts shown there, draft SETL, are not actually HomeNet documents, but they are related and relevant. But I think the main thrust will be on the TLDM document. And then Ted's going to continue to talk about some DNCP security and some HNCP experiences. Any comments on the agenda? I assume not. Okay, so
Ray, were you going to put the HNCP stuff drafts before the name?
Oh, sorry, yes. Yeah, at Ted's request, we'll probably put the DNCP security and HNCP documents actually before the naming architecture ones, so that one of Ted's collaborators can actually be in the room for that. Thanks for the reminder, Ted. Okay, so yes, working group document update. We had a minor update to the Babel profile, which Julius is also going to talk about. Ted's document also going to be talking about. HomeNet.09, as you'll hopefully recall, just over a week and a half ago, I started a sort of final 1 week working group last call on this. I had a couple of comments come back, so those will need to be incorporated, but I've had agreement with our area director that we will then push that directly to IETF last call through his AD review, and that we will kill off the HomeNet Redact 03 document, because there is no longer any need for those two documents to go together as a pair, with basically everything that's needed being incorporated in the previous HomeNet.09 document. We do still have other documents which are still technically around and part of the working group. The latter three in particular, hybrid proxy is still waiting on DNSSD work. The front-end naming delegation and naming architecture DHC options still probably necessary, but are waiting on what we decide as a group to do with the naming architecture as a whole, and make sure that those actually are then fit and are consistent with that whole group. And a sort of bigger question on this first one in the set, which isn't actually a working group document, which is Ted's earlier draft 11 HomeNet naming architecture, which is essentially, as I understand it, been replaced by TLDM simple naming. Okay, clarification from Ted then?
So I'm still holding the intention of eventually making that be a second document that is the extensive or advanced HomeNet naming architecture document.
So hopefully that will address the comments that Andrew Sullivan made earlier to this as well, earlier today. Okay, so without further ado then, let's proceed with Julius talking about HomeNet Babel profile. Would you like the clicker?
Hello.
Julius, would you like to self-drive or of course?
Hello. So I'm Julius Krobacek, and I'd like to tell just a few words in just 6 slides about this draft. So it's a very simple draft that has 2 parts. A first part that tells you how you parameterize Babel in a HomeNet. It says, look, if you have a Ethernet link, use metric 96. Okay, so Babel doesn't tell you what kind. It just tells you have 16-bit metric values. And here we're saying, look, an Ethernet in a HomeNet is metric 96. Or you must do IPv6, you should do IPv4, because obviously if you have two implementations of Babel, one is IPv6 only, one is IPv4 only, they will associate, but they won't exchange any useful routes. So all of those parameters of Babel are written down here. And there is a second part, which is somewhat more technical because it requires understanding of both HNCP and Babel. This speaks about the interactions between HNCP and Babel. So it tells you things that are pretty obvious if you think about it, like if you announce an external IPv6 prefix over HNCP, then you must ensure that it can be routed to. Next, please. Now, this draft is almost ready. It has just two issues. One is that it still refers to the old version of the source-specific routing extensions. So Matthew will tell you a few words about that later. And the other issue are the security requirements. Next, please. So in versions -00-01, and I think that's a typo because the current version is -02, so that should be -01, it says, a HomeNet implementation of Babel must implement HMAC-based authentication with references and must enable and require authentication on a link when instructed to do so by HNCP. And I thought at the time I put it into -00 that reflected the desires of the working group. However, what was not obvious to me at the time is that this requires defining a new sub-protocol in HNCP, a protocol that negotiates keys between HNCP routers and so on. And defining a new sub-protocol for HNCP is out of scope for this document. So in Chicago, I asked for this requirement to be removed from this document and asked to defer security to a different document of which I would not be the editor. Next, please. And the chairs created a committee. And so the committee had a few meetings over virtual meetings, discussed stuff, and finally, the committee didn't do any protocol work, but at least understood that a new sub-protocol is needed. So I think I communicated that badly last time. I didn't make it sufficiently clear that some new protocol work is needed for HNCP. Next, please. So in -03, I removed requirement 5, and I added a security consideration section. And basically, so I've removed bits to get it to fit on a slide, but there are no secrets. It's in the Internet Draft Archive. It says that the security of a HomeNet network relies on having a set of trusted internal links with reference to the HNCP documents that are secured at a lower layer. It recommends that you should not use untrusted links for transit, so that you don't carry any HNCP or Babel traffic or untrusted links. And if untrusted links are used for transit, which is not recommended, then HNCP and Babel must be secured using an upper layer security protocol. And it concludes on a sad note by saying that at the time of writing, no protocol for autonomous configuration of HNCP and Babel security has been defined. Next, please. And so what I would like to ask the working group today is that we wait until the source-specific routing draft, until Matthew's draft is adopted by the Babel working group. So I don't know when it will happen because the Babel group the meeting is later today. And as soon as it is adopted, to update the reference in this draft to the new version. To have somebody review the security considerations that I've written. So I've done my best. I've written them in good faith, but I'm not a security specialist, and I would really appreciate it if a security specialist could review them. And then I would like to ask for last call. Thank you for your attention.
Okay, thank you, Julius. Are there any questions for Julius?
Ted Lemon. This isn't actually a question. I'm going to be doing a presentation on the HNCP piece of this in a minute, which we haven't talked about, sorry. It would be good if we could if we could actually have a conversation about how
With
that,
pleasure.
like what your reaction is to that, which I'm sure will happen, but I just wanted to put in a plug for it.
Well, thank you.
Okay, thanks, Julius. So, Mathieu? Mathieu? Do you want me to drive or do you want to? Whichever you prefer. Yeah.
Hi, so Mathieu Boutier. So I will just present you the new version encoding of the source-specific routing in Babel. So just a few background about Babel in HOMENET. Babel is currently the mandatory routing protocol to implement for HOMENET, and the source-specific extension is required. So the draft has been written a long time ago in 2005, and currently the Babel working group has introduced mandatory bits, which gives a really better draft, simpler, but incompatible with the previous definition. So here was the previous encoding, where we have 3 new TLVs for update, root request, and signal request, pushing the source prefix at random parts in the message. And the new encoding is just to have one source prefix mandatory sub-TLV. So you see it's really cleaner, and it results in better code, simpler, and yes. So because this sub-TLV is mandatory, this extension is not compatible with 6126, but of course the base protocol remains compatible. So as a conclusion for this working group, the source-specific routing in Babel will use a new format which gives a much simpler extension, but which is incompatible with 6126. So we will need a flag day to say, now we use only the new version. As Julius says, this may wait, we may wait for the Babel working group to adopt this new draft. Thanks for your attention.
Okay. Do you have any questions for Mathieu? Okay, well, we're racing ahead of time. So just before Ted starts, sorry, there was some administrative that I forgot to do at the end of our introduction. As hopefully the readers of the list know, this is going to be Mark's last session, co-chairing this. He's stepping down, and I myself will be stepping down after Singapore. It's been 5 years, I think, now.
At least.
I think our first working group session was Quebec in 2000, or maybe 6 years, 2011. Yeah, time to move on. Hopefully get some new blood into the group and maybe actually get some reinvigoration going, because we're burnt out. It's been a long, difficult slog. Terry is still interested in hearing from anybody who's interested in volunteering as a co-chair. He'll still be talking to people this week. If you're interested, please email Terry. But also Mark and I will be available after the end of the meeting if you want to talk with us first. Okay, thank you. With that out of the way, let's push over to Ted, and as we agreed, we'll do the 2 DNCP related documents first.
Hi. So there isn't actually a document associated with this yet, but it's my intention that there will be if the working group agrees that this is the right way to go, which remains to be seen. The motivation here, what triggered me to get started on this was actually the conversation that Julius just referred to. I, as Julius said, completely misunderstood what it was that he was asking me to do in our last meeting, and that's really part of, I think, why the work didn't go anywhere. But I actually got motivated to dig in deep to this about a month ago, and so I, reread all the documents and stuff like that. And the motivation for doing this work is that we would like to be able to secure various protocols that run on the HOMENET. That would include Babel, HNCP. Potentially, it might be useful to be able to do DNS sec signing it's not clear exactly how that's all going to work yet, but basically the key thing is that, and the other motivation is I mean, the other aspect of this is that we don't really know that we need this, but I think we do need this, or I think we will need this, and if we don't do it now, we're going to be in trouble later, so this is why I'm motivated to work on this now. So the status quo right now is that the HNCP protocol offers a key sharing mechanism. Unfortunately, it's not a secure key sharing mechanism in two ways. One is that, as far as I can tell, there isn't a way to configure DTLS to work with HNCP. And so even though DTLS is required to secure the key sharing protocol, there isn't a way to do that, and so therefore it's not secure in that sense. And the other way that it's not secure is that it's a protocol for sharing symmetric keys with more than two entities, and hence is not secure. And essentially what the HNCP protocol does is it tries to nominate the best key, or it chooses one key out of a selection of shared secret keys presented by various DNCP participants. And again, you know, it's a shared secret, so sharing the secret is not really giving you much security. So I think that may be partially my fault that it's this way, because I argued for this years ago and didn't really get involved in writing the document, and so I get what I paid for. But here we are. We need something that's secure, and so this is what I propose. What I propose is that every node that's participating in HNCP should generate a public-private key pair, and each node should share its public key as a TLV in HNCP. It's pretty straightforward. It's really no different than any of the other things that HNCP is doing. So now, because every node is sharing its public key in HNCP, every node has every other node's public key. That means you can do DTLS, because now you have identifiers for every node. You have a key for every node. So if a node connects to you, the DTLS handshake can occur using your key and the key that you know that node has. And this is a way that you can identify which nodes you're talking to. And this works not only for Babel, but it also works for HNCP. So with HNCP, you know, you start participating in HNCP as an unauthenticated participant, and once your key, but you sign all of your messages using your key. And once your key is known to the other participants, then they can validate that you are actually who you claim to be by checking that you signed your HNCP message with your key. And then so you essentially have a tofu mechanism for distributing keys, which isn't great, but what it gives you is the ability to both notice that that a host, to know which host you're communicating with, and to communicate secretly. So for example, if you want to do Diffie-Hellman, now you have a basis for doing that. But that's all it does. It's not security. It's a way of knowing what the node is that can be used in a security infrastructure, but it is not itself making things secure. So just to be clear about that. If I think that this is useful, I would like to have this. I get the impression that you know, Julius asked us to write this up, and so I think that at least in principle, Julius agrees that this is worth doing. I'm hoping that others agree that this is worth doing. And I'm willing to write the spec. If somebody else wants to participate, I'm happy to have help.
Barbara Stark, I think this is exactly the right approach, and I'd be willing to help, because I feel really bad also about not having done anything since Chicago.
Yeah, well, welcome to the IETF.
So Julius Krobacek, so if that is successful, it is much more interesting that you make it. I think we all have this problem of having I think the term is trust anchor in a HOMENET, and if HNCP can provision keys to everyone in the network, distribute public keys, that would be really big, not only from the point of view of the routing protocol and HNCP itself, but especially for all the application layer protocols. Yep. That we want to secure in a HOMENET.
Yeah, I mean, one of the other things that I really feel motivated to have security for is the TLS key that's used by the user interface of your HOMENET. Right now, when you talk to your HTTP server, you aren't using TLS, or if you are, you're clicking through some kind of warning, and it would be nice if we could figure out a way to make that work as well, although that's not entirely clear from what we're doing here, because we're not actually sending certs around. We could also have a cert TLV, though.
And I always find it very unpleasant that the only thing that goes unencrypted over my network is what I print, which usually are the most sensitive things I have.
Good point.
And I was going to say that, using X509 self-signed certificates, you could achieve the same goal, and within DTLS, using TLS handshakes, you can share them around. And if they wanted to have, they could share them around that way.
Yeah, the problem with those is that you'd have to choose, you'd have to elect a signer, basically.
No, every device does its own.
Well, okay, so if every device does its own self-signed cert, then
It's effectively what you said. It's just put in the package of an X509.
Right. You're right. We could just have that TLV, and maybe that's the right thing to do. I don't know. I mean, there is a point to be made that we could be using ACME to get keys for each of these devices that are actually signed by the PKI, and then your browser wouldn't even pop up a warning message when you try to talk to your UI on the device, which would be great. So these are things we should have that conversation and figure out whether bare key is the right thing or whether certs are the right thing. But anyway, I'm glad to hear some positive feedback.
Yeah, I have a couple of questions, but I'm not going to bother standing up. Can you go back to your first slide, please, Ted?
To
first slide.
Yes.
Yes, this one. So it's quite clear from the presentation how this would authenticate subsequent messages between HNRs, but I'm not quite sure I can't see how this addresses the first issue, how you limit which HNRs can participate.
It provides a thing that you can identify HNRs with. The process of limiting which HNRs connect is out of scope, but that is to say, I'm not interested. Well, I don't know. I mean, it might be worth putting that in this draft too, but it essentially it gives whatever or whomever is managing the network a handle to use to identify bad actors, and to also, or alternatively, a handle to use to identify trusted actors.
So it would be more reactive than proactive prevention.
Well,
or limitation.
We haven't gone down the path of defining the user interface of the HomeNet.
Yeah.
And that's what this does is it basically allows all of the routers in the network to prove that they are who they are, and to repudiate to repudiate routers that are not identified. And then those routers can show up in the user interface, and the end user can say, well, I don't recognize that router, right? The routers can actually have like something printed on the box that says, this is the ID of this router. And then when you go into the user interface, you can identify that that's the router that you wanted on your network. And if you see a router that you didn't want on your network, well, you can check the box next to it that says, don't allow this one.
Yeah. Well, it's looking very useful. By way of an aside, I participate in a monthly DNSSEC coordination call with various other DNS vendors and DNS folks. And on our last call, a good half of that call was taken up in the discussion of how you would distribute things like DNSSEC trust anchors within a home scenario. It happened, obviously, part of my area. And Steve Crockett was driving that discussion, and this is exactly the sort of thing we're talking about needing for that.
Right.
Thanks. David Skenazy, Apple. So first off, this is really cool. I would really love for the trust anchor, or however we want to call it, the trust establishment, the first step, to not be out of scope. Because as we've seen with most of the security issues, this is one of the sharp edges. And if we just say, oh, we'll punt that down the road, then everyone will just not implement it. And at the end, it'll be just pointless because anyone can just roll new public-private key pairs anytime they want to. So I think this should be an integral part of our design.
So let me say this. I think that I agree with you entirely about your motivation for wanting to do this. I think making it part of the same draft is not the right move, because I guarantee you that this draft will go faster than the other one, because the other one is a harder problem. And I'd like to have this solution published as quickly as possible. That doesn't mean that we don't do the other bit, or that we say the other bit isn't required. Right now, nobody's making HomeNet routers that I know of, so we have a little bit of an opportunity gap here where we can fit in this work. And so if we're all motivated to try to make what you described happen, I mean, I think there's a variety of different ways we could do it. We could do it with proximity, with codes on things and user interfaces. We could do it with buttons. I mean, we could do it with like, okay, I'm going to plug the two routers together using these ports, and then I'm going to say go. I mean, there's lots of different things we could do, but basically what we're talking about is coming up with a laundry list and publishing it, I think, because I don't think that we have, it's not clear to me that there's one method that we can require. Like, we can't require NFC because NFC isn't available with everything. We can't require a UI on the front of the box because some boxes will have it and some won't. I mean, your Alexa device, you could just say, hey, Alexa, add this router, and then plug the router in. And Alexa will say, identified new router. But that only works if you have an Alexa or an Apple Home or whatever the Google version of that is. We can't, I don't think we can mandate a single user interface, but I think having a laundry list of user interfaces and requiring that at least one of them be implemented and available is probably worth.
I mean, within the scope of our charter, that is a difficult problem, as Ted said. I mean, everything else that we talk about here is software or firmware.
So
whereas
I totally agree. I wasn't recommending that we enforce, say, this particular hardware solution. By that I mean this particular radio, this particular button UI. However, the laundry list approach is the one way to guarantee that no one will do any of them or that two vendors will do different ones. Mm-hmm. And also, this really does impact what you were talking about earlier. Do we use raw keys versus X509? I don't feel strongly about either of them, mm-hmm. but it impacts this. So moving forward on this, we can realize that we painted ourselves into a corner because we're missing this bit or that.
So what I would suggest we do is actually write out that laundry list anyway, not because we think it's definitive or the final thing, but because it gives us something to work with, and then sit down and think about, like, well, can we draw a circle around parts of this laundry list and say, if you implement any one of these plus that other one, that's enough? Or, I mean, can we come up with something that's reasonable to require? But that's when I say we need to write a laundry list, essentially what I'm saying is we got to start somewhere, and I think that's where we start.
That sounds good to me.
Great.
Thanks.
Thank you.
Yeah, thank you.
Okay. Hearing no further questions. Now I will tell you an adventure story. To the authors of HNCP and the various demons that I'm about to complain about, please know that I really appreciate the work you've done, and this is not a slam. This is just like, there's still work to do. I am very late to this game. I had been meaning to set up HNCP and had made a couple of failed attempts to set it up over the course of the past 3 years. But I finally actually got around to doing it about a month ago when I was trying to do this security research, because I didn't actually really have a clear mental picture of how HNCP worked, even though I read through the documents. And so I figured the best way to find out is just set it up and see how it works. So I have a home network. It's got a Comcast link, and I also have a tunnel to Hurricane. And I have IPv4 and IPv6. I have an Edge router, which is an Ubuntu Linux server, and I have a bunch of Wi-Fi routers. They're all running either OpenWRT or Lead. So I figured I'd already gone down the path of discovering that getting HNCP running on Ubuntu was not trivial, but I really wanted to get it running on Ubuntu, and I did eventually. Thank you, Julius. But of course, obviously, I wanted to use whatever was convenient on the OpenWRT routers, and so I did that as well. The implementations that I had to choose from were HNetD, which I could not get to build on Ubuntu for love or money. PySima, which looked interesting but didn't have any documentation, and SHNCPD, which had some documentation, but the main thing that was great about it was that the code was very readable, and so I was able to, it's relatively small, so I was able to just kind of grok it, and I was able to get it to build, and that was great. So I wound up using HNetD on OpenWRT because it was a package, and I wound up using SHNCPD on Ubuntu because it was compilable. So I installed it on Ubuntu, I installed it on OpenWRT, I enabled it enabling it on OpenWRT was actually quite a bit of work. The documentation was sufficiently detailed to get me through it, but I had to really think about what was being said, and I had to really build a mental model before I could get it working. Like I couldn't just kind of flip a switch, because you wind up having to actually change sort of the default interface layout of OpenWRT, which is a real pain. Obviously, in production, we would like that not to be that hard. Enabling it on Ubuntu was actually pretty easy. And then the network went down. Boom. You know, I was just sitting there hacking, and so the network didn't go down when I turned it on. It went down about 10 minutes later, and the reason it went down was because all of my leases expired. As soon as the lease expired, oh, sorry, I actually have a slide about this. As soon as the leases expired on the upstream from the OpenWRT router, which is how I was connected, the OpenWRT router deconfigured all of its IPv4 addresses on all of its interfaces. And my host then lost its IP address, and IPv6, for whatever reason, wasn't working, and it really sucked. And it took me kind of a while to get my network back. Like I had to go around and like go to the serial console of my OpenWRT router, and I had to like, you know, turn on my TV and switch it to the console of my Ubuntu box. It was kind of a pain. Julius?
So all of that is, Julius Krobacek, all of that is a little bit rusty because all of that is stuff that I did 2 years ago. But if memory serves, the reason you lose your 10/8 when you lose IPv4 is because the gateway stops acting as NAT gateway to give a chance for a different functioning gateway to elect itself as the NAT gateway.
Yeah.
Okay, so your NAT gateway said, okay, I don't have any IPv4, let somebody else take care of NAT. So I believe that is working as designed.
Yes, so I'll get to that in a minute. So this is actually not the last slide, even though it says conclusions. So I don't really feel like this is quite ready for demoing. If you're a true believer, you can get it working. If you're not a true believer, chances are you're not going to get it working. That is obviously, we are not done yet. So, and you know, that's understandable. I mean, this is a prototype. We got a lot of work to do. The point is that I got to discover that face to face, and now I actually am a true believer and want to get it working. So I had a whole bunch of questions when I was suffering through my network collapse, which, by the way, my wife was using the network when this was happening, and I was not expecting the network to all go down at once, and so it was really embarrassing. It took me a while to get it back. So where's the problem? Is it in the specification? Is it in the implementations? Are they all broken? What's the deal? And I don't actually know the answer to those questions, but here's what I think based on what I've observed thus far. There are some things in the specification, and that would particularly include the thing that Julius just referred to, which caused the part of the problem that I saw, which is that I couldn't even talk to my routers over my IPv4 local NATed addresses. That's broken. That's got to get fixed. That's not the right default behavior. Another reason that it's broken is because we don't have a naming architecture, and so even though I'm pretty sure that I actually had IPv6, it's been a month and a half since I did this, so I don't remember the details, but my recollection is I did have IPv6, but I couldn't figure out what the IPv6 address of the router was. And so I couldn't get to the user interface, so I had to, anyway. So getting a working naming architecture would really help with this, because then I could have just said, you know, connect to because there's a default name for the router that you can connect to that's supposed to be guaranteed to work. And when my IPv4 routing was working, it was working. So if we had naming working better, then that would work. And there's just a bunch of integration work to do, and I think this is not a hard thing to do, and I'd really like to do it. I'd really like to get to the point where if somebody's curious about HNCP or about HomeNet, we have like a very short set of instructions that we give them about which version of OpenWRT to download, and if you're running Ubuntu, here are the packages you install, and it just works. I don't know if that's realistic, but I think that's something we should at least try to do, because if we don't, we're not going to do the learning that we need to do to find the flaws in the work that we've done thus far. So one of the challenges I ran into is that the spec is like, you have to read the whole spec, and then you form your mental model, and then you read it again a couple of times, and then eventually you understand how it works. I think that could probably be improved, and I think it would be worth doing that. It might be that it gets improved in an HNCP BIS spec, or it might get improved in an informational document, an ops doc, or something like that. But we got to do something about this. I think that the way it's done, the amount of work that's involved in understanding the network to the point where you can debug it is too much. And I think that HNCP actually isn't that complicated, so it shouldn't be that hard to understand. So we should do something to help. And that is my last slide. Comments or tomatoes or?
Hello. So I'm Pierre. I'm one of the implementers of HNetD. So thanks for your bug report. I've never had such a formal bug report ever in my life. So can you provide me the logs, or did you document?
I couldn't figure out how to get the logs.
Okay, did you document what you experienced in a draft? Or in a mail or in a bug report?
So I was in kind of a hurry, and so I have not done all the documentation. I would like to work with you on actually solving these problems. I mean, that's actually what I'm alluding to here. I think, I'm not saying somebody else should go off and do this integration work. I'm saying I would like to do this integration work, and I'm happy to hear that you're interested in participating.
I appreciate a lot that you're working, you are testing it. I have to admit that the implementation is a bit old. Mm-hmm. That said, the way you present it, you're discussing the validity of the protocol based on your failure to make it run in your network.
Right.
And that disturbs me quite a lot. Like in front of an IETF audience, you come, actually we got students like 19 years old, they can make it work. So I'm sorry to be that harsh, but you were on the slides. You literally put on the slides like not good for demo, not good for like.
Julius Krobacz, okay, wait. Students at an elite school.
I'm not sure that makes me feel any less insulted, but but so just to quickly speak to that point, what I'm getting at is not that. So of course, I'm perfectly capable of getting this stuff working. I'm not speaking for myself. I'm speaking for the actual end users who are the targets of this technology, the people that we actually want running it. For them, it's just too hard. Even for a reasonably knowledgeable network person, unless they really, really want to get it working, or it's their assignment, or they're a student who has a lot of spare time, which, looking back as a student, I remember having like an amazing amount of spare time, which I didn't think I had at the time. But anyway, those aren't our target audience, and this has to work for our target audience, and that's what I'm getting at. It's not, again, really, my point is not to say that you did a bad job. You did a great job. It's just that we aren't done yet, and there's a lot more work to do.
Right. I just want to point that, yeah, HomeNet is not running out of the box of the OpenWRT routers, because when you install one, well, it's not enabled by default. Mm-hmm. So you have to explicitly enable it, which is already too much for an end user. Yeah. Second point is that your use case, if I understood it right, was with tunnel upstream interfaces, which is not exactly the base audience either. So you use tunnel interfaces, right?
I actually never got the tunnel working. I wasn't even really concerned about the tunnel. It was just I mentioned my configuration for completeness.
Right. Well, normally it's working. Like we are testing it. It works. Mm-hmm.
Well, I mean, part of the problem is that my edge router was not running HNetD because I couldn't get it to build on Linux, on Ubuntu. So.
Hi, I'm Bob Hinden.
Hi,
Two
Bob.
comments. So I don't see the problem with V4 stopping to work. But I think you should look at the ICMP v6 node information queries. Ping 6-W or just pinging the all nodes multicast address will make it very easy to learn all the v6 nodes, and then you could have gotten the address of the router. Mm-hmm. So I sounds to me like getting being able to do local v6 communication. You'll be able to, when v4 breaks again, you'll be able to then get to your router and reconfigure it.
Yeah, that makes a lot of sense, and thank you for pointing that out.
Mark Townsley speaking as a participant. Regarding who's our target market, it's good to keep the end user in mind so that we can create something that really someone else can put together and make deliverable. The target market for this group should be, Arrow and Apple and Belkin and D-Link. I think I'm doing that in alphabetical order.
That's
Yes.
kind of scary.
But all, somebody that's going to sell it and support it, not to mention the service providers as well that have their home gateways.
Mm-hmm.
So it doesn't have to be perfect. Okay,
So,
it doesn't have to be completely turnkey. We need to give them the tools for them to turn it into something that's perfect.
if our target market is somebody like Ubiquiti or Google, then I agree with you. But unfortunately, if our target market is some of the smaller router vendors, they aren't going to do that integration work. And the way that you address that market is that you put the code in OpenWRT and make it work. You have an OpenWRT distribution that out of the box is doing the right thing.
They're still going to skin it with something.
Of course, yeah, no, but that's all they're going to do. That's my point. The only thing they're going to do is skin it. So if we want it to work, it's got to work in OpenWRT.
No arguments there. We've been doing that since the very first day of trying to get it working well in OpenWRT. Just don't set your sights so high that you can never reach it. They can do a little bit of work as well. And it might start with Ubiquiti and Google and Apple, and then the other guys follow. Who knows? That's all.
Hi, George Michelson, APNIC. So Ted, I actually think what you had was an extremely real experience, and I don't think it should be disregarded. I think that sense that something should be intuitive and you should be able to construct from scratch. It's understood to have components, you build from the standard components, and then you hit a moment where it doesn't work. I actually agree with you. That's a very strong signal something isn't baked yet. And it might be as simple as there's a wiki that's not being kept up to date describing some of the stepping stones you have to bridge over. Or it might be diagnostic elements. I'm going around in my head thinking, if I were building systems and they had potential to become unreachable, I'd want a heartbeat signal coming out of the router and some packet form on the wire saying, me, 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 so that you could have at least done low-level TCP dump or something and seen packet flows on an unbound interface, discovered what you wanted. I mean, sure, ZeroConf, DNSSD, something would have been great, but even primitive things should have been there. So I personally think what you've had is a very real and valid experience. And I go to, it's not quite baked yet. It should be possible to do what you tried to do. It should have worked. And you're not done. And if you couldn't get it to fly, there's a story there that we have to think about.
Thank you.
Lee Howard, thank you for bringing this, field report. I think this is exactly the kind of thing we ought to be welcoming. A question, was there a HomeNet project at the hackathon this week?
There was no HomeNet that I'm aware of. There were many using OpenWRT.
Okay, yeah.
From what I saw.
Yeah, that's pretty common. There are lots of lots of stuff going with it.
I should say there was one on multi-prefix MPVDs, which is sort of a spin out of this work.
Yeah, it's related.
The HomeNet stuff has been done so many times at the IETF. It's really, we've moved on to other things.
Okay, it sounds like Ted's saying that, hey, there's still more to do, and maybe we do need to wait until we've got the naming stuff at least spec'd, and that would be, room for more implementations. I could imagine doing an interim hackathon maybe at Ted's house.
That'd be great.
We have 2 bedrooms extra.
Fantastic.
Actually, on that note, Lee, actually what I think might be quite useful would be to see if there are people who are interested in doing this and would like to form set up your HomeNet with HomeNet support group.
I did specifically want to say, yeah, a support group. Interop testing is a little more what I think I'm hearing than additional coding.
I mean, the thing is, you don't really know, like doing it at an IETF really is going to work because that's not where you run into the real problems, right? It's when you've got a raw network that you have to cram it into as opposed to you're building a hypothetical network. Julius?
So I'd just like to expand on Bob's point about naming. So one of the reasons for the apparent complexity of HNCP is that it is a link state protocol that floods the whole topology of the network. And I mean, the main algorithm in HNCP is Pierre's algorithm for link assignment, and that algorithm doesn't need full topology. It could very well do with a diffusing approach. But it was decided that for debugging reasons, you do want the full topology. Okay, so in addition to having the standard protocol that are implemented by OpenWRT, so things like node request or simply having the names of the nodes over DNS, over if you are locally connected, you do have the full topology in HNCP, and you do have the names of every single of your nodes in HNCP. And here there are two issues. Issue one is we don't have the tools. You would like to be able to launch a command on your local node and get the full topology. And by the way, this router here, it's green because you flooded over HNCP that the green router is called whatever. So we have built such a tool last year with a student, but the tool never reached production quality because there are two kinds of students, those who bring their stuff to production quality and those who disappear immediately after they got their grade.
Right.
And she happened to be the second kind.
Sorry.
But we do have the code, we do have the tool that gives you that, and we don't yet flood the color of the router over HNCP because we don't know how, there is no interface on OpenWRT to find out what is the external color of the plastic enclosure. So that's a missing feature.
We need a camera that with a mirror.
Exactly. Second point. We want those tools to work without any authentication. I think so. And if somebody were to add security to HomeNet, to HNCP, it would be good to think about this use case. You want to be able to determine the topology of the HomeNet even if you're not authenticated anywhere.
Yep. Yeah, thanks. I would actually love to see that code even though it's not production quality.
Pierre Pfister again. I just wanted to point that in the HNetD, when you install it on OpenWRT, part of the GUI, you get a graph.
Yeah, that's really cool.
Of the topology. Yeah, and that's one of the things that we presented in many bits and bytes and so on. So that's why, yeah, we are not so much active in terms of demo anymore, because we have been in the past a lot. So I think, yeah, the code might be a bit rusty, and yeah, help on maintaining HNetD is welcome, really. We need help. And for the wiki, like, yeah, there is no wiki because we don't spend time to do the wiki because we don't have time to do the wiki. So help on that as well is welcome.
Jordi Palet. I am a user of OpenWRT and actually from LEDE, which is the revamped name of OpenWRT. And I believe it was about 9 months ago, I was testing the HomeNet stuff and it was working for me. So unfortunately, because it was working, I didn't take out any report or anything because it was working.
Right. So were you using HomeNet as your edge router?
I tested several configurations. Yeah.
Okay. Cool. Part of my problem was my insistence on using Ubuntu as my edge router. Makes life difficult. I take it we're being chivied.
No, not really.
Well, thank you everyone for that discussion. I now have yet another thing to present, and this is a lot longer. So sorry about that. So the reason this is long is because I'm not actually getting a lot of feedback that tells me that people are following this work. I'm just curious, has anybody, who here has read, I know there's one guy in the back, and there's one guy up here in the front. Who else has read the relevant documents? Thank you, Tim. Okay, that's not too bad, actually. So I'm gonna kind of give an overview. I'm actually gonna skip some of the slides. They're here for completeness in case somebody who didn't follow the entire presentation wants to read them. And of course, you can ask questions, and I'll go back to them. But most of the slides, some of the slides are here just because they might be useful for answering questions. So first of all, the goal of the naming architecture, ability to look up names on the internet. We have to be able to make it possible to look up names on the internet, obviously. We want to be able to publish services that are reachable anywhere in the HomeNet. We want to be able to discover services anywhere on the HomeNet. And for those of you who are familiar with this problem space, the reason why I'm emphasizing that is because MDNS does not work on an entire HomeNet unless the entire HomeNet is only one link. So non-goals, these are things that we've talked about, but are out of scope for this document. That doesn't mean we won't ever do them. Publish a DNS zone for the HomeNet in the public DNS. make service discovery available off the HomeNet, allow off-HomeNet devices to publish services in the HomeNet, and secure HomeNet naming and service discovery using DNSSEC. These are all things we might want to do, but not in this document. Name resolution. So what name resolution means is that we have to be able to tell devices who to talk to in order to resolve names, provisioning. We have to be able to provide resolution. We have to answer the questions when they're asked. One slight challenge is we don't actually know how to solve this problem. What if you're multi-home and you want to access Netflix and you look up your Netflix server using the resolver for ISP A, and then you connect to the Netflix server with a stream on ISP B? That's going to suck. And more importantly, that's going to generate phone calls, and nobody wants phone calls, and that's going to limit deployment. So we need to figure out how to address that. I'm going to hit that point first because it's really important. Well, I already explained this. There's my theory about this is that there are two kinds of hosts. There are multi-home fake hosts. I mean, fake means capable. And there are multi-home not fake hosts. And all hosts right now, because we haven't defined how this is going to work, fall into the category of not fake, but hopefully some will go into the fake category quickly. And I'm hoping particularly that folks from Apple and Google who have a lot of influence on this, and maybe folks from Microsoft will participate in that if we figure out how to do it. The idea with multi-home fake hosts is that if you're multi-home fake, then you get prefixes for each of the homes. We'll say there's two, so ISP A and ISP B, you'll get a prefix for both ISPs if you're capable of handling it. If you're not, you only get one prefix. And the HomeNet has to figure out which one that is, which is a problem. So if you're capable, you get one prefix and you get a list of DNS resolver IP addresses, the addresses of DNS proxies, and it's a different list for each ISP. So you will contact a different IP address if you're looking up a name that you're going to use to connect using ISP A versus if you're looking up a name that you're going to use to connect using ISP B. The reason for that, I'll get to in a minute. I don't think we really need to solve this problem for IPv4. We don't really have multi-homing for IPv4 anyway, so we're not really losing anything. But it was one of the key things we wanted out of this, out of the HomeNet architecture, was to be able to multi-home. And if we can multi-home, but multi-homing makes your life miserable, we haven't succeeded. Andrew?
My name is Andrew Sullivan. I'm just wondering whether you could say why you think the host is going to have a theory about which ISP it's going to use.
It has to. I don't think it's going to have a theory because it makes sense in the abstract. I think it has to have a theory in order to succeed. So think about your Google browser, right? Or your Firefox browser or whatever, right? It is, you say go to netflix.com. When it goes to netflix.com, that's got to work. And so because it's got to work, that means that the browser has to figure out which ISP it's talking to, which sucks, but there isn't a way around it. The only way around it is to just say you don't do multi-homing.
Yeah, so this feels very much to me like the economics answer of, in the long run, it will all come out fine. In the long run, we're all dead. And the same thing is true here, right? That if every application has to start knowing, oh, I'm making this connection and now I need to know which ISP I'm going to use, multi-homing isn't really a whole lot of use. So it's hard for me to understand the use case here.
So Andrew, I mean, the general expectation, and this is the way it's been implemented in Android, and I think in Mac OS and iOS, is that the application just says connect to netflix.com. And then the operating system has an API that goes and does all of the math that I'm talking about. And so from the application perspective, you don't do anything differently at all, except that you have to use this API. If you try to use connect, if you try to use get host by name, it's not going to work. You just say connect to host, and that works. And this is something that we've discussed at length, both in MIF and I think in some other working group, but I can't remember which.
Yeah, so I understand that that's what the background is here, but I think that you're going to need a lot more. So first of all, the document doesn't have this stuff in it right now. So
yeah. The document is not up to date with the slides.
So this is at the very least I think an instance of the thing that I sent to the list, where what we're doing is changing our scope a little bit in order to make it simple. And that might be the right thing to do, but this is probably not what everybody thought they were going to get out of our plan. That's really the remark I'm making.
Yeah. So actually, Andrew, I'd like it if you could answer a question about what you just said, which is because I pretty much agree with what you just said, except for one thing, which is what will we have done instead?
Right, and that has always been the worry, right? That we set a high bar for ourselves without a clear plan for how we were going to be able to do it. Mm-hmm. And if now our answer is, gee, you can't do that, then our architecture is fundamentally wrong.
Well, but
that could be the right answer, yeah, but I want us to make it explicit, not something that we just wander into.
Right, but our answer isn't, gee, we can't do that. I mean, we had a working group, which unfortunately got closed a year ago, that was working on this specific problem. So our answer is you can totally solve that problem. And in fact, there are existing stacks that have pieces of the solution to that problem built into them already. They don't have this particular piece because this is actually a slight enhancement. So the piece that they have is I've got two interfaces. When I ask a question about how to connect to Netflix, I want a different answer for different interfaces, and I want the connection to go out the interface that the answer came in on.
But this is sort of the point that I'm trying to make, right? Mm-hmm. That a given host in the HomeNet doesn't even know that there are two ISPs, right? That's a problem the router has.
This cannot be solved at the router.
I
isn't
know.
a way to do it.
I'm aware of that. That's my point.
So I mean, this goes back to happy eyeballs and things like that. That first, you need to figure out which of your connections is going to work better. And I've long been a proponent that happy eyeballs should not just be about IPv4 versus IPv6. Happy eyeballs should be about what is the best connection that I can get. Yep. And so that's part of it. And then, the first thing you do with any connection is your DHCP query, and that gets into the weirdness you're talking about. I mean, your DNS query, sorry. Jet lag.
I was wondering.
And one of the problems that you're coming up to is that different domains, different networks have different stuff in their DNS servers, but also even when they go to the authoritative servers, they get different responses based on where the query is coming from.
Yep.
But this also gets to the fact that the home is a different domain. And so this idea that there is one DNS is a real problem, and it's been a problem for a long, long, long time, because for this same long, long, long time, we've had different domains having different private stuff within their DNS servers that the other domains don't have. And it seems to me that somehow what we really need is a happy eyeballs for DNS so that you can find the right domain where you're, oh, happy eyeballs does that. David solved everything. I'm going to let him talk.
Thanks, Barbara. David Skenazy. So yeah, to answer these points, happy eyeballs does that. So this actually, like Ted was saying, we still have a bunch of work in this working group, but this particular problem is solved. We've had this for a long time, at least on iPhones, where you have a Wi-Fi interface and a cell interface, and you want to use Siri. You want something to go really fast because users don't want to wait. And can you elaborate and be at the mic?
To the mic, please, George.
Well, to finish what I was saying, one of the things it does is that it does DNS for each interface, because indeed the answers can be different, and then it can send a query over that. Enhancing that to use the multiple source addresses that you've received from the various ISPs on your home network is by no means a stretch.
Right.
Like, this is not hard.
Yeah.
We have the technology.
Yeah, I totally agree with you, David. I mean, from my perspective, this looks bad because it's like when you're solving a quadratic equation, right? You multiply everything out, you get all of these terms, and it looks really messy, and then you go through and you figure it out, and by the time you're done, it's like really simple. But you had to go through that process, and that's all this is. It's really not that hard. It's just a matter of doing it, and as David has said, most of the code has already been written. It's just, we need a couple of little extra pieces of shim technology to get the information into the stack on the iPhone or on the laptop or whatever, so that it can do what it's already doing when it's got two physical interfaces. It's exactly the same problem.
Okay. I should point out that HomeNet, of course, is chartered not to rely or require host changes, which does make our work a little bit difficult.
Well, that's why we have the solution for non-fake hosts. But I think we need to solve the problem for. Yes. We actually need a solution to this problem.
We are chartered to find things like this, and actually then hopefully somebody will spin up a MIF working group or something like that, for example. But,
what a thought!
Yeah. I have a perfect transition. Perfect transition for another draft, which is happening in Interia or 6-man. I mean, David is co-author, and we have an array option for that. It's called multi-provisioning domain, discovery of multi-provisioning domain, and the ability to get some more information for. I mean, I'm repeating stuff that most people here already heard this morning in 6-man. There will be another presentation in Interia and another presentation in Captive Portal as well. So please come and comment this draft as well.
Thanks.
Just one final thing, that I also dislike those proxies, the DNS proxies, and I really don't want to require a DNS proxy to be able to manage my different domains, even though the home domain is not on a different interface really than the other interfaces. And so I think as we allow ourselves to have multiple DNS servers, we also need to get away from this idea that the home has to be, you check the home before you check anything else, and the home has to.
I have really bad news for you, Barbara. Really bad news. Remember that we're doing service discovery and naming. And service discovery is going to be in home.arpa.
Yes, it is, but that isn't necessarily going to be distributed on every single one of your home network routers. In which one is the one?
No. What I'm saying is not that therefore every HomeNet router has to be doing DNS proxying all the time. But what I'm saying is you have to have a proxy in the HomeNet, because the query has to go to some place in the HomeNet. Because otherwise, if you send
there has to be a DNS server.
There has to be something responding to DNS queries, whether it's a server or a proxy or whatever. I'm calling it a proxy because that's the least common denominator.
But to suggest that it has to intercept all DNS queries and say, is this home.arpa or is this external? And if it's external, then proceed to launch the query externally, as opposed to the device itself querying the local DNS server and querying the other
devices
servers.
Can't do that. How would you do that?
Happy eyeballs, multiple DNS servers.
No, that's not the way. That's not what. See, remember, the whole DNS architecture has this idea, which we all believe in, sort of, that the DNS is uniform. So whichever,
it's not.
But that's what it looks like, and that's what every stack assumes. So we can't demand that everybody change their stacks to do this querying of random.
It's a really bad assumption.
George from APNIC. Ted, how many slides have you got?
I've got, we're about a third of the way through the presentation.
So It's not that this is a low-value conversation, because it is absolutely a high-value conversation, but I think it's at the wrong time. I want to hear the rest of your argument.
I tend to
think it's
agree.
better you get to continue so that we can understand contextually and do this later. Because you're early in the stage in this. Right?
I agree with both of your points. One, I think we really do need to have this conversation, and two, we need to finish this slide deck too. I think that having this conversation also is something that is not entirely a HomeNet thing, although it's certainly highly relevant. Stuart?
Yes, I agree we should move on, so I'll make a very quick point, which is a request for everybody discussing the microphone. The term DNS server is easily misunderstood. So let's say recursive resolver or authoritative server, because they're very different beasts, and giving them the same name is confusing.
Yeah, and indeed that distinction is part of why I think that we were having the confusion we were having in the conversation. So yeah, let's move on a little bit. So this is just some more text about how to provision devices. I don't think we really need to go into this right now. Just know that this information is here. If you want to talk about it later, we can. Again, I'm calling it a DNS proxy because DNS proxy is like a switch in a network. You might plug directly into the router, or you might plug into the switch, but the switch is the lowest common denominator. So that's why I'm using that term. And what it has to do is it has to determine whether the name is local or not. If it is local, it sends it to the local resolver. If it is not local, it sends it to the ISP resolver. And as I mentioned earlier, the source address, the reason why the resolver for ISP-A has a different different address than the resolver for ISP-B is so that the one actual piece of software that's sitting there listening for these requests can look at the source address and say, oh, this is a query for ISP-A, or oh, this is a query for ISP-B. That's all it's for. To Barbara's point, this doesn't have to be a proxy. That's just minimal. Service discovery. So the main model for service discovery is the one we've all been talking about for a long time. I don't want to go into a lot of detail about it, but it's the discovery proxy, formerly the hybrid proxy. I have written a new draft, which I will be presenting in DNS SD on, I think, Wednesday. Yeah, and this is, Stuart and I have basically been conferencing every week for the last 2 or 3 months about this. And so we've done a lot of work. And so Stuart's got a whole bunch of cool stuff, which you'll see in here. I've got this is my main thing. I actually coded this up because I wanted to make sure that I didn't miss anything. And so it's a split model where you have a very simple relay in every HomeNet router. And then you have one or more discovery proxies that are talking to those relays and providing actual DNS lookups, or answers to DNS lookups. So every link has its own subdomain of home.arpa. There's an advertising proxy zone. Stuart, are you still using that name, advertising proxy? I realized when I was writing these slides that we hadn't actually talked about that in a long time. So the advertising proxies, well, you'll see that on the next slide, but this is just a terminology question.
I'll refresh your memory. You actually talked me out of doing that.
Oh, okay.
The discovery proxy lets a remote device that's not able to multicast on the link reach in from the outside and say, do these queries for me. The advertising proxy was imagined as the mirror image of that, which is a service that's remote, can reach in and say, advertise this for me using multicast. You argue very convincingly that we should actually try to be moving away from multicast. We should not be encouraging more use of multicast because it's expensive on Wi-Fi, it's expensive and unreliable and hard to do on mesh networks. There's a number of reasons why. Multicast is valuable for certain zero configuration scenarios, but as the network gets bigger, it rapidly becomes not a good solution.
Thank you. So in place of advertising proxy in the slides that follow, please consider using the term authoritative name server.
Jabberscribe request. It happens that I know the name of everybody who's come to the mic, so I haven't needed it, but please do say your name when you come to the microphone.
Yes. Okay, so basically what this means is that there are n+1 zones where n is the number of links. or possibly there are 2n+1 zones, because actually I think the discovery proxy has 2 zones for each link. But anyway, the point is there are per-link zones, and then there's a zone in which things that use Stewart's registration protocol will register their names. Hosts browse all of these zones, either directly or through a discovery broker, which is another thing that Stewart has a draft about. So the required infrastructure here is that every HomeNet router can, if needed, so every HomeNet router has to have the following things on it. It has to have a discovery, at least, actually it doesn't really have to have a discovery broker. It has to have a discovery proxy. It has to have has to have the software to do a authoritative server for the home.arpa zone, and it has to have a discovery relay. Every HomeNet, when it's running, will have probably a discovery broker, certainly at least one discovery proxy, and should have a this is the problem with name changes in flight, should have an authoritative server for the home.arpa zone. And every link on the HomeNet will have at least one discovery relay. And ideally, actually, it's probably better to just have one. But anyway, so a typical HomeNet might look kind of like this, right? It might have home.arpa, that's the authoritative, the zone for which there is an actual authoritative server with state. It will have the link1.home.arpa zone, which is the zone on which we receive MDNS stuff for link number 1. It will have it'll have 3 links like that. And then home.arpa, assuming that we have a discovery broker, home.arpa will be listed as the only browsing zone. So when you want to browse using this, remember this is using RFC 6763 DNSSD. So it's actually using DNS to do service discovery, not MDNS. So when you do DNSSD, you look up, you get a list of zones that you have to browse, which can be an arbitrarily long list, although ideally it's not arbitrarily long. And so here we're saying if we have a discovery broker, you're just going to look up in one zone, home.arpa. So what happens is the host sends a message to the DNS proxy or whatever, asking the question, can you find me PTR records for the domain name _IPP._TCP.home.arpa? The DNS proxy says, oh, that's home.arpa. I'll send that to the discovery broker. The discovery broker then sends a message to the to the authoritative server for home.arpa asking if it has any PTR records for IPP.TCP.home.arpa, and at the same time it sends to whatever discovery proxies it's aware of the same question, only it actually explicitly names each of the links. Okay, Mike, yeah. Okay, and then the answers that come back, suppose that there's one of the printers is using the registration service, and so it actually registered a name in the authoritative zone. That will send back an answer that yes, there is an IPP.TCP.home.arpa in PTR regprinter.home.arpa. I'm using like sort of geek readable names here. Actually, these names might be human readable names like printer space @ space TED space desk or something like that. It doesn't have to be regprinter, but it's just easier on slides. And then suppose there's also another printer that's only doing MDNS, and that's on link 1. It'll also send back a PTR record. I'm not putting the relay proxies in here because they're just kind of there for, they're essentially just a way to extend for the advertising proxy to ask, or sorry, for the discovery proxy to ask questions on multiple links. So the broker gets back answers from 2 different sources. It puts them together and sends the combined answer back to the DNS proxy, and then the DNS proxy sends the combined answer back to the host. So this is the sort of topology that we've got here. We've got a number of different places, and some of these functions might actually be combined. Like it's entirely possible to have a discovery broker that's also a discovery proxy and just kind of merges those 2 functions. And you could have, in principle, you could have the discovery broker, the advertising proxy, and the discovery proxy all be one piece of software that's doing all 3 tasks, or they can be completely separate and be speaking DNS protocol to each other. It's entirely up to the implementation how to do this. But the functions need to be there in the sense that it needs to be possible for the broker to talk to a discovery proxy. Actually, it doesn't really need, the broker could just be talking, the broker could be talking to its internal discovery proxy, which is talking to a relay proxy on each link. And so there's actually no need for an explicit break between the discovery proxy and the discovery broker. But, you know, they are separate functions in the functional chart. I am going to skip these slides because I've already explained this, but they're here for your reference. So basically, the reason I put these slides in here is in case anybody needs to drill down more and wants to ask questions. But I don't think that we need to go into detail because I think everybody in here already knows this stuff. So the status right now is that we actually have a lot of the specs written. They're not done. They're mostly -00s, but we've thought this through pretty thoroughly, and I think that we're not too far away from having something which is either mostly complete or entirely complete. And I did an implementation at the MDNS relay. Right after that, Stuart and I changed the spec. So it's not in sync with the current spec, but it'll be pretty simple to update it. And actually, the code will be cleaner, so it's great. The registration protocol is, nobody's done an exact implementation of the registration protocol, but sorry, I don't know how to pronounce your name, has done a piece of it. And the code that he's written should be eminently adaptable to do what Stuart's written. So my point being, aside from that one little thing that we tubed on earlier, if the working group decided that what's in this document as it is now is the right thing, we're actually pretty close to done. And I'd like to encourage the working group to think that way, in the sense that it would be really nice to be done. So if the working group is, and I've come to the working group with various proposals at various times and been shot down, I'm really hoping that the working group isn't going to shoot this proposal down, because I think it's pretty complete. I think it does what we need. I think it's good. I'd like to do it. Julius, do you still hate me?
I've never hated you. I'm enjoying our discussions a lot. Yeah. Julius Krobacek. So I'm sure I'm not the only person here looking at that specification and thinking there's a lot of moving pieces in it. Fewer than in your previous proposal, but there are still quite a few. And I think it might be worthwhile to sit and think really hard, then wipe the blood off our eyes and check very carefully whether we actually do need all of those moving pieces. And I've tried to start a discussion at some point many months ago on that, and your answer was your proposal doesn't meet the requirements. At which point I asked what are the requirements, and you answered, very good point, they aren't written down yet. So what I would really appreciate, so that we can feel more at ease with this, and I'm not saying that I'm against or in favor, I'm just saying that I would feel much more at ease if we could have a list of requirements, and perhaps rather than a formal list of requirements, which are always difficult to read, a list of scenarios. If we manage to solve those 5 scenarios, we are fine. Something like that, not necessarily an internet draft, a mailing, a carefully redacted mailing to the mailing list would be fine, but just to have a basis to discuss stuff.
Yeah, around. I think that's a reasonable request.
Hi, George Michelson from APNIC. So I think you're right to say that this is something that should probably be close to done for the level at which it can define how to do things. And I think some of the confusion in the conversation at the microphone, at least for me as I understand it, is that I think people are wanting to see a much higher abstraction of behavior and talk about decision logic for the right name and the right address, which I hold non-microphone noise to say that's a multi-dimensional problem. And I think saying, oh, we solved that in Happy Eyeballs. No, you didn't. What Happy Eyeballs does is it projects a single dimension of problem to say what best is. And on my platform of choice, Android, there is another dimension. There's a hidden knob that says preference Wi-Fi over cellular at all times. And it has no consciousness that my cellular provider may be offering 0 zilch, zero charge, off count access to high bandwidth TV. And the CDN provider that I get from DNS lookup may well say, no, use this Wi-Fi binding, go suck it on Wi-Fi, consume my Wi-Fi limits and leave me unable to use Wi-Fi to do other work. It's a multi-dimensional problem. The best mapping is a higher order question. What you have laid out here is an architecture for saying, based on coming up from the ground, based on being multi-provider, how do I find what name to address mappings there are? And you introduced, actually I will say, I think Stuart was absolutely correct to say, please use the correct labels for the DNS functioning elements. I think that was an extremely important comment. And you do that, and I respect that. You introduce an idea called a broker. I like that idea. I see brokerage as a very good abstraction for what is the best choice, because it puts it into that multi-dimensional question. It depends. The best is not what happy eyeball says. It's a complex decision, but you are describing an architecture for building that model. I like that. I think you should close off on this. It's good.
Thank you.
Stuart Cheshire from Apple. I just want to start off by thanking Ted for not only doing all this work, but taking the initiative. At the last IETF, we agreed to focus on this, and Ted set up a weekly 2-hour conference call every Thursday, which was kind of grueling, but it kept both of us honest, and we had to make some progress for the next week's call. So thank you, Ted, for making that happen. I think we were so burnt out on that we didn't have time to sync up on this. I think one of the things we should do is make some diagrams that will make this a lot clearer than words. I don't know whether we'll get that done between now and the DNSSD meeting on Wednesday, but maybe we could try.
If you have a good way to make diagrams, I'd love to see it.
Okay. And the other thing I will say for people's information, one of the drafts I did as the result of this is the roadmap draft, which is an attempt to explain how some of these moving parts fit together and to explain why each one of them is there. So that also could do some ASCII art diagrams in it, which I didn't have time to do. But for people who are interested in figuring out a bit more, that's why I wrote the roadmap, because we realized there were getting to be many moving parts and it was not obvious to outsiders what they were for.
Mm-hmm.
I'm Andrew Sullivan, and my employer tells me that I don't speak for them, so I'm not going to mention who they are. I agree, first of all, with I think what Stuart was just suggesting, which is that the number of moving parts here is probably actually the irreducibly small set, and I think that that's okay. But I'm a little concerned about the suggestion that we heard a moment ago that we don't really have requirements, because we do, right? We had this architecture document that we published, and it's got a lot to say about this, about what the naming thing is supposed to do, and this proposal, as I said to the list, and I suggested earlier, doesn't entirely meet that, and I'm mostly persuaded actually that that's fine. So I guess what I want to ask is, you've got this last bullet here that says we could be done in fairly short order and get on to the advanced HomeNet naming architecture. And I want to ask this time why you think that that would be a thing we ought to do, because I'm not totally convinced. If we think that this is too complicated, people are going to find the next one to be, non-Euclidean geometry, and it's probably not going to get published.
Yeah, so, the problem with any... This is the reason why I actually sat down and wrote code, because the problem with any spec that we theorize about is that it's really easy to theorize and you often miss the details. And unfortunately, when you stop theorizing and start writing code, you realize that there are complexities that you hadn't thought about, and that's what you're seeing here. What you're seeing here is that this has actually been implemented. The implementation is not big. It's like 2,500 lines of C code, which I would really rather not have used, except that it's got to run on OpenWRT. So it's really not that hard to do. And of course, my implementation doesn't have all of the stuff in it, so I guess I'm exaggerating slightly. But it really isn't that bad. The thing that makes it look bad is that all of the details, to the best of my ability, are here. And to me, it feels like we're close to completion because we're kind of to the dregs. We're kind of like the multi-homing thing is kind of the hardest problem that's left. Everything else seems totally tractable. I have a specification for how to manage the interface between if you read the MDNS relay doc, it actually has a specification for how to manage the interface between the MDNS relay and the discovery proxy. And that would fit very nicely into HNCP. So in fact, it was written with HNCP in mind. I think we really are very close to victory here, and it's not as bad as it seems. And therefore, I think that if there is interest, and I don't know that there is, I mean, I get the impression that there are a fair number of people in the working group that are interested in the advanced HomeNet naming architecture. If I'm wrong about that, then absolutely we don't need to do it. I mean, I'm interested, but one person being interested isn't enough. So if it's just me, great, we can stop. And frankly, this is a lot of work. I'm enjoying the work, but I don't need to keep doing it. Yeah, it's really up to the working group whether to do the follow-on work. And indeed, if we don't do the follow-on, if we decide that we really don't want to do the follow-on work, there are some simplifications we could make to the simple HomeNet naming architecture. I don't think that's worth doing because I think that even if we decide now, oh, we don't really want to do this, we might decide in 5 years, oh, we really do want to do this. So I don't know. I think it's an open question. Does anybody? I mean, I'm curious. Maybe if I could get a show of hands, does anybody even remember the previous HomeNet naming architecture document? Okay, of those people who remember it, do you remember it fondly or unfondly? So raise your hand if you remember it fondly.
I think some questions are better left unanswered.
I know how you feel about it, Julius. So we didn't really get a show of hands there. So I guess when I asked if anybody remembered it fondly, and no one raised their hand, so maybe that's the answer to my question.
Well, from the chair, it's not necessarily that it was not fond. I think longer term we do need to do this. Actually, part of my rationale for standing down is that I would actually like to really get into some of this stuff, and I think I can do that better from the floor rather than from the chair. So Singapore or later, I really would like to get into that sort of stuff. I propose that actually we go to a call for adoption on the list on TLD, this is not TLD, of this particular draft, it is TLD, yes, on this particular draft, and then press on with it. I would kind of like to reinforce, I think, what Judith was suggesting, that we need maybe a little bit more detail about the end-to-end process. I think one of my concerns from the chair with the earlier documents we had around naming, and in part why the front-end naming delegation and stuff has been parked for so long, is that even as a naming guy myself, I couldn't follow the end-to-end resolution process both for internal names and for external names with the documentation we had. And I think it's important that it's clear to people how hosts do get all the names, and from the point of view of the host. Okay, are there any other questions on that? Okay, thank you, Ted. So I have one last thing. As I said earlier, this is Mark's last session as working group chair. So I would like to sincerely thank him very much for his help over the last 6 years, and I hope the rest of the working group will feel likewise, and thank you for that.
So long, and thanks for all the fish. And yeah, it's been a wild ride. Some incredibly good work has been done, and I appreciate every single time somebody gets out there and tries to make a HomeNet work and make it better and contribute more code, because that's what we're all here for. I can't wait to go buy one of these and install it in my home and it just work. Make it happen, guys. Thanks.
Okay. Thank you, Mark. Okay. Sorry. Okay. If you haven't signed the blue sheets, could you please do so? We've got one set here. The others must be out in the room somewhere. And thank you all, and I will see you in Singapore.
And thank you.
It's subdued. It's all very quiet.